Right, next, let's deal with number 3.4. So we'll deal with this one. Okay, again, as we mentioned in the previous video, we look for the highest common factor first. In this one, in fact, there's going to be two methods of factorization that we can use. And generally, the highest common factor is going to be the first thing that you look for. So if you look at both of those, there's a factor of 2. 2 goes, or common factor, 2 goes into both of our terms over here. Right, so we are going to write down the 2, which is a common factor, and then we open a bracket. So if this term is divided by 2, you are left with the x squared. If this term is divided by 2, you are left with a minus 36. Right, so now let's have a look at what we have inside this bracket over here. Okay, so as we've mentioned in the previous video, the first thing we look for is the highest common factor. The second one is the difference of two squares, right? So let's just talk about those words quickly. Difference of two squares. Difference refers to subtraction. Okay, so whenever we have difference of two squares, we have to have this minus in the middle over there. If it's not a minus in the middle, then it's not difference of two squares. Okay, so that's the first thing. You must have your minus in the middle over there. Okay, the next thing, squares. Let's talk about squares. All right, so what are perfect squares? For the difference of two squares, generally we look for perfect squares. So what are perfect squares? Perfect squares are 1 multiplied by itself is still 1. 2 multiplied by itself is 4. 3 multiplied by itself is 9. 9. 4 multiplied by itself, 16. 5 multiplied by itself, 25. 6 multiplied by itself, 36. All right, I'm not going to complete the table, but all of these values over here, and these are our perfect squares. All right, so make sure that you can finish this table up until at least like 13, which is going to give you 169. So go at least that far, and because you know these values, it will make certain things easier to recognize. Okay, so understand what perfect squares are. So again, the definition, difference, there has to be a minus. Perfect squares, right? Perfect squares, this one. Okay, let's maybe use a different color here so we can distinguish between what we're doing here. This one over here and this one over here, both of them have to be perfect squares. Okay, so x times x, so this one over here is a perfect square. 6 times 6, this one over here is a perfect square. Right, difference of two squares, difference is a minus, and we have two perfect squares on either side. Okay, so how do we factorize the difference of two squares? Okay, let's maybe get rid of some of these things. This 2 that was our common factor is going to stay there. When you're dealing with a difference of two squares, this generates two sets of brackets. So we start by making two sets of brackets. Okay, what goes into your bracket? We will take the square root of the first one. So x times x is x squared. So we put the x's over there. Okay, so let's say that again. Two sets of brackets. The first thing that goes in, square root of the first one. Okay, then the square root of the last one. So the 36, 6 times 6 gives you 36, so the 6 goes there. Square root of the first one, square root of the last one, and lastly, the one bracket gets a plus, the other bracket gets a minus. All right, so what did we say? We looked for the difference of two squares, so there had to be a minus in the middle, had to be a minus in the middle. There had to be a perfect square on the one side, a perfect square on the other side. When we saw that, we made two sets of brackets. We took the square root of the first one, went into both, square root of the last one, went to both, and then the one gets a plus, one gets a minus. Okay, that's the difference of two squares.